Okay, let's look at question 13, part B. Right. So this is complex numbers. So let's go through what is given. ZD is given by this. ZK is equal to this. Right. First we have to show what? Real ZD is less than or equal to modulus of Z. Right. This is just theory. Right. So ZD is what? R cos theta plus I R sin theta. So then what is the real part of Z? Real part of Z is R cos theta. And modulus of Z is what? R, no? That part is clear, no? Why? R squared cos squared theta plus R squared sin squared theta will give you what? Square root of R squared or R using Pythagorean identity. So then what do we have? Real Z is equal to modulus Z cos theta. And what do we know about cos theta? Cos theta is between 1 and minus 1. So then we know what? Real Z has to be what? Less than or equal to modulus Z. Because you can multiply this equation by modulus Z. So you will end up with what? This. So modulus Z cos theta is less than or equal to modulus Z. So using that we can get the first part of the question. Right. Then the next part. Second part. Right. So we have to first create what? Z1 and Z2. Z1 is what? Using this one. R1 cos theta 1 plus I sin theta 1. Z2 is what? R2 cos theta 2 plus I sin theta 2. So then modulus Z1 is what? Modulus Z1 is R1. Modulus Z2 is R2. Right. Now let's create Z1 over Z2. So that is going to be R1 cos theta 1 plus I sin theta 1 over R2 cos theta 2 plus I sin theta 2. Right. So we'll multiply by the complex conjugate and get rid of the denominator. Cos theta 2 minus I sin theta 2. Here cos theta 2 minus I sin theta 2. So what do you get? R1 over R2. I will leave it outside. And then what do I have? Cos theta 1, cos theta 2. I become I square. So minus I square sin theta 1 sin theta 2 will give you what? This one into this term gives you minus I square, which is plus 1 sin theta 1 sin theta 2. And what else do we have? Plus I sin theta 1 cos theta 2 and minus cos theta 1 I sin theta 2. that is all thing over what? Cos squared theta 2 plus sin squared theta 2, which is 1. So this part is 1, right? This is r1 over r2. Then this one you have to simplify. What is this? This is an identity, you know. Cos theta 1 plus cos theta 1 cos theta 2 plus sin theta 1 sin theta 2 is what? Cos theta 1 minus theta 2. Take I out, then you get the same expression for sine. Sine theta 1 minus theta 2 is the third and fourth term together, right? So then z1 over z2 has this form. So then modulus of z1 over z2 is what? r1 over r2, and r1 is what? Modulus of z1, and r2 is modulus of z2. So there's the proof of the second part. Modulus z1 over z2 is same as modulus of z1 divided by modulus of z2, right? So this question is basically all of it is theory, right? We did those two. Then, right, using the two things we proved, we can deduce this, right? So then what can I write? Real z1 over z1 plus z2 using the first result is going to be what? This one, less than or equal to the modulus, no? Then using the second result, we can break this into what? z1 modulus over z1 plus z2 modulus. So we have the result we were looking for, right? Then the next one, this one we have to prove, right? Let's see how to prove that. Real z1 plus z1 plus z2 plus real z2 over z1 plus z2 has to be equal to 1, right? So we'll use the left hand side. Real z1 over z1 plus z2 plus real z2 over z1 plus z2. So here we are going to use this result. We can use this one. Real z1 plus real z2 is same as real z1 plus z2 together. So sum of a complex numbers real part is the same as if you do real part of the first complex number plus the real part of the second complex number. So these are complex numbers. So this can be written as what? Real, add them together, z1 plus z1 over z1 plus z2 plus z2 over z1 plus z2. So this becomes what? What's the complex number inside? Real 1. So that is just 1. So there's the proof of that one, right? Then what is the next one? Right, hence show this, hence show this is true, right? You have to use this one to do that. We know this, no, and we know this result, so we'll use both of them to get it. So real z1 over z1 plus z2 plus real z2 over z1 plus z2 is equal to 1. No, better to write it like this, then it is easy to see. This side 1 equals this, then use that result. This part is going to be what? Greater than or equal to modulus z1 over modulus z1 plus z2, and this one is again greater than or equal to modulus z2 over z1 plus z2 modulus, right? So then just multiply out the modulus of z1 plus z2. So then you get the result. Modulus of z1 plus z2 is less than or equal to modulus of z1 plus modulus of z2. Right. So part B was just theory. This you learn when you study complex numbers. Right. Okay. So and then next we'll look at part C of question number